It takes true grit to make sandpaper, as in abrasive grains. People have been using abrasive minerals to sand and polish things for centuries. Today, these minerals undergo heavy processing to make the grade. From very superfine to very coarse. Whether you're working on metal or wood, the right grade of abrasive grit is essential for finishing the job. The factory starts with bauxite, a naturally occurring mineral that resembles clay. They add alumina, a white powdery material that's actually derived from bauxite. The bauxite and alumina are blended with other minerals, then released into an electric arc furnace. Here, 3 large electrodes use intense electrical current to heat the mix to over 3,600 degrees Fahrenheit. That's hotter than an active volcano. In fact, the mixture looks a lot like lava as the minerals melt and blend together. Standing well back and using a long ladle, a technician takes a sample for chemical analysis. If the mix is right, the molten minerals are emptied into a big steel pot. The searing liquid weighs several tons, so a crane is needed to transport it to a cooling area. "24 hours later, with the material hardened, it's time to bring in the wrecking ball. It cracks open the hardened concoction, which is still quite hot at the core. The wrecking ball is dropped repeatedly to break up the hardened minerals. Next, the lumps of abrasive material are transferred to a conveyor system. Metal-plated crushers break them up into fist-sized chunks. A magnet picks up any excess iron. And then it's into the roll crusher, where iron cylinders grind the chunks to bits. Workers assemble screens in decreasing mesh sizes to make a kind of shaking sieve. It sifts the mineral particles through the screen with largest mesh first, then continues to sort the grits in progressively smaller sizes. For some perspective, we placed a quarter against the various mesh sizes. As you can see, only the finest particles could pass through the tightest weave. The bits of grit bounce across the screens and fall into hoppers, a different one for each size. The coarsest grains will be used for rough sanding jobs. The smaller the grain, the finer the finish. The finest grits are virtually microscopic. The next step is to inspect the grain shape. A sample is funneled into a cup. Then it's weighed. A higher weight means the bits are densely stacked and therefore blockish in shape with blunt edges. A lower weight means they're flat and sharp. A different test is used for the most minuscule grits. The particles are suspended in an electrolyte solution. Then, an electrical charge is applied. This allows inspectors to count and evaluate the grits via computer. Now, these abrasive grits are ready to be packaged and shipped out. Coming up, we'll go to the sandpaper factory, where the abrasive grits meet their ultimate destiny. We'll have the nitty-gritty.